This is an interesting question, so let me write it down. So there are two cases in it. Let's start with the first case. There are 20 blue balls. Let me use the black color. There are 20 blue balls and 14 red balls. Uh, so each time you take two balls out, if they're of the same color, let's say both are blue, you're going to add a blue ball to it and keep the red as it is. So it's B minus 1 and R finally. If you want to take two red cards out, you're going to do the same thing. You're going to add a blue ball, take a blue and a red, you're going to add a red ball. So you can see how the sequences are, and an important thing to notice is that R is always even if you start with an even R, because it's going to go in. You can either subtract 2 or let me just make this right. Yeah, you can subtract 2 at a time, so it can go to 0. Now the question is, so you know for a fact that R can never be equal to 1. So the last remaining ball, if you're talking about, it could be R in two cases. If R could be odd, or if R gets over finished after blue. Let's evaluate both the cases. See, if you take out two red balls, firstly you're starting with number of blue balls that are greater than red balls, so 20 greater than 14, in that for sure. And at a time, if you look at it, if you're going to take both a blue and a red ball out, uh, let's say 14, you'd have to do this. It would have to be all blues and no reds, which has a very small likelihood of happening, right? It's either you're going to all be drawing out blue balls, you're going to be drawing out all red balls, which is a very small likelihood of happening, right? We are not really looking at that case. If you're going to look at a strong livelihood, strong likelihood, uh, right? We think what's also asked in the question is what you have an unlimited supply of blue and red balls. That's all fine, but if this is what you're going to be arriving at, right? Also remember that every time you remove two blue red balls out, you're gonna be left with a blue ball. Can we actually have a case in which all the blue ones go out first? Well, that would be the case in which, let's say, you start with 20 balls, remove two each time. How will that look like? I'll show you. I'll just go on to show you that. Let's look at the case in which you're only drawing out blue balls. Let's say you draw blue only, you're doing BB only. For some reason, it keeps happening. So from 20 you go to 19, you go to 18, and so on, and you're left with one blue ball in the end, right? Because blue B only reduces. A BB can happen, let's say, until you have two blue balls, but then once you're left with one blue ball, you won't have this BB case. In this case, BB can't happen, right? BR could happen. BR could still happen, and RR could happen. Okay, so you could still have a case whose likelihood is very small. But in this case, if someone is going to ask you, I think the original question is, what will be the color of the last ball left? I don't really think we're considering this case, because you won't really have one last ball left. You're going to have more than one last ball. Uh, in that case, if you consider that as the question, and because R can't be even, and you're not looking at a solution where you're like, we can't determine this, you would have to say it's most likely going to be blue, because you will never have a single red ball left. I personally feel that this question, for one, is not complete. I think they should have given us more constraints, because here itself we can see a case where you do all BB till you're left with one blue ball, and then you do BR, which also leads you to, you could always be left with an even number of red balls. Obviously, the last ball can't be red in this case. I think, okay, if that's what the question is, at least the title says so. In the question, I don't see them describing that well. But if you go by what the title is telling you, yes, we can never have a single last ball left. So it could be, it's a likelihood that the red ball, it's a blue ball when it's even. But let's talk about the case where it's odd, right? Where it's odd, why should it be, uh, right? if you start with an odd number of balls, why should it be blue or red? So same constraints again, but the total number of balls in this case it would decrease by 1 each time, right? You can always add them up and see it's always going to be b plus r minus 1, b plus r minus 1, b plus r minus 1, b plus r minus 1 in all the three cases. So that's there, right? So if we start with 13 red balls, right? So drawing one blue and one red ball or drawing two blue balls keeps the number of red balls unchanged. We've seen that. These are the two cases. Uh, Also drawing two red balls would decrease it by 2, right? So each operation, would decrease it by 1. Number of red balls can never be 0, by the way, because if you're going to reach 13, 11, it will be 1, and after 1 you can't have the minus 2 because this is one ball left. So mathematically it's impossible to have a minus 1 red ball left. So in that case it will be a red ball, that's the last ball. But with E1 it's going to be a blue ball, that's the last ball, right? Because you will never have one red ball left. So that's the answer to this question. If you have any doubts, please put them in the comments down below. Thank you.